Let's take a look at a few more logarithm properties. The first one we want to take a look at in this video is the exponent property. And basically the exponent property says if I have an exponent on what we're taking the log of, log base a of b to the x power, we can actually drop that exponent down in front here and make this into a multiplication, x times log base a of b. This, of course, as our other properties, works in both directions. Quick little kind of show you why this works, if you will. If we look at log base b of a squared, for instance, we know from our other properties that that's the same as log base b of a times a. And if we got a multiplication, we said we could split it into an addition of two separate logs. So now we have a log base b of a plus a log base b of a. Well, those are like terms. We now have two log base b of a's. So you can kind of see how that works. That, once again, is not really an actual proof, but we'll kind of show you what's going on. Let's try this just a couple of times. So what can we do? We can take this 3 out of the exponent, we can drop it down in front of the logarithm. So now we've got a 3 times log base 2 of x. Okay. With this one, we can split this, based on what we learned in our previous video, into a log base 2 of 4 plus a log base 2 of x squared. And I can expand that some more. Obviously we can drop the 2 down in front here. But the other thing we can do is take this 4 and make it into a 2 squared. So let's go ahead and do that. Let's make this into a log base 2 of 2 squared plus a log base 2 of x squared. Let's go ahead and drop those exponents down now. Make this into a 2 log base 2 of 2 plus a 2 log base 2 of x. Now the only thing we have left to do here is take a look at this. Log base 2 of 2. This says 2 to what exponent gives me a 2. This is something we can simplify right here. We'll have a 2 times a 1, because 2 to the first power would give me a 2. So we have a 2 times a 1, which is just a 2, plus 2 log base 2 of x. That would be our final expanded version. Let's work on condensing. Well, condensing, we're going to move that 3 out from in front, and we'll make it back into an exponent. So we'll have 4 cubed, or rather a log base 5 of 64. Do the same here. We can put that 2 up as an exponent. Please realize, though, even if those parentheses weren't there, it is going to be the exponent of everything that the log was once of. So we're going to now have a log base 3 of a 2 squared and an x squared, if we kind of apply that exponent to both pieces. And we can simplify this guy all the way down to a log base 3, or condense him down to a log base 3 of a 4x squared. That brings us to our change of base formula. Change of base formula. There are times, and we'll find them soon enough, where we want to change the base from some base, let's say in this case base A, to another base. In this case we're going to choose base C. So I can take any logarithm. A log base A of B can simply become a fraction of two separate logarithms, both of the same base, where the original base is now what we're taking the log of in the denominator, and the b stays with the log base c now in the numerator. I want you to be aware, though, be very careful, be cautious, okay? These two things are very different. They both involve logs and fractions. One is a fraction of two logs, one is a log of a fraction, okay? This here is the division, or a fraction, of two logs. Okay, this is a log of a division. Or you could say fraction in either case too. A fraction of two logs, or a log of a fraction. And they mean two very different things. This one was right out of our change of base formula. Remember, we can use these properties in either direction, so it will work either way. So a division of two logs becomes a single log with a different base. However, a log of a fraction, we already saw in our previous video, can become a subtraction of two separate logs. So let's use our change of base formula to rewrite as a log of base 10. We're going to use log base 10 right now. Eventually, we're going to realize that log base 10 is the same as common log. In other words, log where there is no index down there, no base value. So we're going to write it with a base 10 for right now. We're going to write this as a log base 10 of 5 over a log base 10 of 6. That's all this takes. Write it as a log base 10 of 19 divided by a log base 10 of 3. That's how we use our change of base formula. I hope this is helpful as we continue to explore the properties of logarithms.